Assalamualaikum and a very good day to the panel, Dr. Azlin binti Muhammad Azmi, Associate Prof. Dr. Ahmad Muhammad Ihsan bin Mohamad, and to everyone. I am Karuna Anisha binti Ahmad Shafi'i, UiTM Shah Alam student, Semester 7 from Faculty of Mechanical Engineering. My supervisor is Dr. Al-Hassan Salami Tijani, who supervised me throughout this semester. Due to some limitation, my title has been slightly changed, but it is still within the same scope. I am delighted to present to you my final year project 1 entitled as Effects of Temperature and Wind Speed on Economic and Environmental Feasibility of Different Solar PV System in Malaysia. We will go through 4 sections of this research, which is firstly, Introduction, Literature Review, Methodology, and the last one is Expected Result. Firstly, Introduction. Over the past century, there has been dramatic increase in renewable energy, especially in the photovoltaic industry, as demand has increasing for good quality energy yield predictions. Currently, the rapid development of solar PV panel in the market is high globally with improved technology efficiencies at reasonable price throughout each year. The climatic factors such as solar irradiance, ambient temperature, and wind speed have the significant impact in the efficiency of producing power generation of any solar PV plant. The technology for solar PV panel plant can be divided into 2 generations. The first generation consists of monocrystalline and polycrystalline, while for the second generation is thin film, which is in this study we use amorphous silicon. Next is problem statement. Recently, due to increasing demand, high oil prices as well as environmental crises have led to rapid growth of renewable energy. The climatic factor can be one of limitation in solar energy. The installation of solar panels can be affected by ambient temperature, wind direction, and solar radiation. In particular, the specification of solar PV provided by the manufacturer does not meet the accurate result in evaluating the efficiency of solar PV system. Hence, the climatic parameters must be taken into consideration. The objective of this study is, first, to study the effects of ambient temperature and wind speed on the performance of 3 different types of solar PV panels. The second one is to determine the economic and environmental impacts assessment in the present year and future years. The second part is literature review. We will be looking into types of solar radiation, materials of solar PV, and effects of temperature and wind speed. Types of solar radiation. According to T. Stoffel in Concentrating Solar Power Journal, there are 3 types of solar radiation. The first one is direct normal irradiance, shortened as DNI. It can also be called as solar beam radiation. It is used to define amount of solar radiation from the sun directly straight to the surface of Earth. Next is diffuse horizontal irradiance, DHI, or scattered solar radiation by molecules and particles in the atmosphere. However, those particles are still through the surface of the Earth. Technically, all radiations except DNI in the sky dome can be classified as DHI, including reflected or scattered by clouds and solar radiation reflects on the ground and reflected again by the clouds or atmosphere. The last one is global horizontal irradiance, GHI, defined as geometric sum of DHI and DNI. The formula for GHI is the total summation of DNI multiplied with cos SZA, which stands for solar zenith angle, and DHI. Materials of solar PV. As you can see in the illustrated figure, the PV panel type is divided into 2 groups. One is crystalline and the other one is thin film. The crystalline consists of monocrystalline and polycrystalline, while thin film consists of amorphous silicon, copper indium gallium selenide, and cadmium telluride. Let us see the details for each material. The first one is monocrystalline. It is a single silicon crystal which fabricated from an ingot of single crystal. It has the highest efficiency compared to the others with 26.7%. The price of $1.1 per watt peak. The market share is larger and popular due to the ease manufacture. Referring to ISE 2019, the global annual production is 67% in 2019. Next is polycrystalline. It is a combination of many crystals in a block of silicon. Rectangular ingots of multicrystalline panel are formed and sliced into thin wafers. It's slightly less efficient compared to monocrystalline with 22.3%. The price is $1.06 per watt peak. It has the longer lifespan and great stability. Referring to ISE 2019, the global annual production is 27% in 2019. The third type of solar PV is amorphous silicon, which is in the group of thin film. It is a non-crystalline form of silicon. Being lightweight is its benefit for good constructability. It has the least efficiency with 10%. The price is $0.84 per watt peak. The demand for amorphous silicon panel decreasing, which constituted only 0.3% in 6% of total thin film production. Effect of temperature and wind speed. PODIA 2020 claims the output power generated is directly proportional to the temperature of the PV module. As you can see, this is the formula for the performance of solar panel, where Tc is the temperature of the PV cell, Ta is the ambient temperature, and Tnoct is the nominal operating cell temperature. The solar irradiance is 1000 watt per meter squared. A typical installation is fixed at a solar irradiance level of 800 watt per meter squared. The efficiency of solar PV module can be determined as the temperature of PV cell is obtained. As you can see, this is the formula for the efficiency of solar PV module. The parameter of efficiency ref, beta ref, and temperature ref are provided by the manufacturer. In order to determine the wind speed, this is the formula to determine the wind speed, where the value of a local wind speed is 1 meters per second, while V velocity F is the measured wind speed 10 meters above the ground. Payback period. Payback period refers to the length of time it takes to recover the initial cost of investment. The formula for payback period is initial investment divided into cash inflow per period. Next is net present value. The net present value method as a capital budgeting or financial appraisal of a project with a long-term period. As you can see, this is the formula for NPV, where S is an initial investment, Q is cash inflow, R is discount rate, and T is the number of periods. And life cycle cost, LCC. Life cycle cost is a method of determining the economic value of a design project decision. The formula of LCC is the summation of cost of solar PV, cost of inverter, cost of installation, and lastly is cost of operation and maintenance. The life cycle cost can be calculated annually by using this formula, where I is inflation rate, N is operating years, and D is discount rate. The electrical cost, which is cost of 1 kilowatt-hour, can be calculated after determining the value of ALCC. Unit electrical cost is equal to ALCC divided by 365 multiplied with electrical load. The methodology consists of flowchart, preliminary feasibility, performance analysis, and economical and environmental models. This is the methodology flowchart for this project. The details of each section will be explained in the next slides. Preliminary feasibility. This is the proposed residential house for this project. It consists of solar panel, DC-AC converter, PV meter, and fuse board. All electrical appliances that usually used in a house are included. The electricity supply will be connected to the TNB grid. From the data collected, average daily energy required is 25.60 kWh per day in residential house, 179.18 kWh per week with annual energy consumption of 9,344 kWh per year. In this study, there are 4 selected cities, which is Kuala Lumpur, Bayan, Kota Baru, and Kuching. Performance analysis. Tool that will be used for this project is PV-SYS version 6.7.0. Two outputs can be obtained using this simulator. Firstly, simulation for solar radiation output. By using Metronome version 7.1 software, which is available in PV-SYS, the function is to provide meteorological data monthly, which are global and diffuse irradiation for each selected location. Next is simulation for solar PV output. There are 7 parameters that need to be considered. All the descriptions are in the table. Economical and environmental analysis. The economical model consists of payback period, net present value, and life cycle costs. As for environmental models, the greenhouse gases can be reduced by using solar PV. The carbon emission can be calculated by using the data in the table. The emission factors is 1 kWh for 1 kg. Expected result. The expected result of global irradiation for each city, which are Kuala Lumpur, Bayan, Kota Baru, and Kuching, has been generated in the PV-SYS by using the Metronome 7.1 software. As you can see in the result, Bayan has the highest solar radiation in Malaysia throughout the year. The results are one of the output simulation for solar radiation. Here is the Gantt chart of my work schedule for final year project. Everything has done according to the plan, except for the methodology part, which is a little bit time consuming due to some limitation which slowed down my work progress. This is the project milestone for my final year project 1. Every work is organized weekly and work progress will always be updated to my supervisor. Thank you for listening. For any inquiries, you can directly email me at anishamakfi@gmail.com. Thank you.